5 of x, and the other one, log base.
1 over 5x.
Okay, let's do 1/2. Because I don't want you to think that there is any connection.
Okay.
Good. So first of all, we start with log base 5 of x. And I'm asking myself, what type of function is this? And the answer is log. Okay, if it's log, then it's not a friendly function. Then I'm going to ask myself, okay, is this a pure function? Yes, it is pure. No transformations whatsoever. So then what will be its domain?
0 to infinity.
Yes, that's all I have to write. So that's the reason why from a long time ago I started torturing you by asking you, okay, you have to graph a function, what is its domain? Because that's what you have here. I don't want to see anything else. Because some students write between negative and infinity and then cross out power. No, there's no need. It's 0 to infinity. Good. So let's pick some numbers. Okay, I'm going to pick 1. I can't.
Oh, yeah.
I can. It will be undefined.
5.
Okay, 5 indeed. Now, that is a very good idea to choose powers of 5. Why?
Easy to figure out.
Right, because if you ask me log base 5 of 3, I'll say. But if you ask me log base 5 of 25, 5 of 625, yes. 5 of 1, yes. 5 of 1/5. Yes, I can give you the answer. But if you ask me log base 5 of 3, I'll say 5 raised to what power is 3? I have no idea. Good. So let's plug it in. So log base 5 of 1/5 is a. This is equivalent to, I have no idea what this is, but I can change it into raised to equals. Good. So what power will I raise 5 to get 1 over 5?
-1.
Thank you. Now let's plug in 1. Log base 5 of 1 is a. Now do you understand why the most important relationship or concept in this chapter is being able to change a log equation to an exponential? We haven't done anything else, but we went back and forth because I can't solve anything other than there are other ways too. But I truly believe that this is a very powerful concept. So I don't know what this is, but I can change it into raised to a equals
1.
So what can a be?
5. 0.
0. Good. Now I apply it to 5. Log base 5 of 5 is a. 5 raised to a equals 1, only 0. Only 5 raised to 0 will give us 1. Only 5 raised to negative 1.
Yeah.
So now I have 5 raised to a equals 5, so a must be 1. And let's also do 25. What would you say for 25? 5 raised to what power is 25?
2.
So let's graph this function with what we have, but not before talking about end behavior. So here I have 0 and 1 and 2, and then eventually 3 and 4 and 5 and 6. And where am I going this way? Very good. I'm going towards infinity. Now let's go this way. A -1, and then I have 1 over 25, which will give me -2, and then I have 1 over 125, which will give me -3, and then -4, and then -5, and then -6, and then which direction am I going here?
0.
But these are negative values.
Yeah, negative. I'm sorry, negative.
Very good. Because remember, the domain is 0 to infinity, but the range of the log function is? Right, the domain of the exponential, which is everything. Good, so now let's graph. So you said 1/5 negative 1. So here's what I'm doing because I'm graphing a function with asymptotes. Bless you. Although this is an overkill because the y-axis is right there. So I have so this is 1, so this will be negative 1, and this 2, 3, 4, 5, that would be 1. So here's the graph. Okay, if I want to graph this with a graphing calculator, I just want to show you something. So in y equals, if you'd like to put in, let's say I'm going to put in just natural log x. And I use standard. So if someone on the test or final exam copies something that starts here at -2, goes through 1, 0, and goes to infinity, I know that the student didn't study this function, right?
Yeah.
Because it doesn't start here. It starts here. Right? So please understand, the calculator has limited capability. It will not give us all the answers. Okay. With a vertical asymptote and starting or the arrow going down. So I've seen it. Yes. So I've seen it in papers. Students do this. Sorry. Students do this with no arrow, no nothing. So I know. I don't want you to copy something like this because it's incorrect. But that's what the calculator gives. Okay, let's look at the other one. So f of x equals log 1/2 x. Again, I'm going through a lot of questions, and I say, okay, it's a log. It's not a friendly function. It's a pure log, no transformation. So the domain must be 0 to infinity. I will pick some numbers, of course, powers of 1/2. So I'm going to have 1/4, 1/2, 1, 2, and 4. It's undefined at 0, of course. So again, I'm going to use this wonderful concept. When I plug in this in, 1/4. Log base 1/2 or 1/4 is a number. I have no clue, but I know how to convert it into something that I can work with. And that something will be 1/2 raised to a equals 1/4. And now I'm thinking, what do I raise 1/2 to get 1/4? So exactly 2. 1/2 times 1/2 is 1/4. Then I'm asking myself, log base 1/2 or 1/2 equals a. So what should that be? 1. Then I'm asking myself, log base 1/2 of 1. 1/2 raised to 1 power, what power is 0? Now I'm here, log base 1/2 of 2. What should that be? Yes. 1/2 raised to -1 would be 2. And then finally for 4. Right. Where am I going here and where I'm going here? And I'm thinking now. So log is the inverse of exponential. Exponential is defined on all real numbers. It returns 0 to infinity. Log is applied to 0 to infinity and must return correct. So this direction is, and this direction is. Good. So you said 1/4, 1/4 2. Then you said 1/2 1, and then 0, and then 2 -1. And stop torturing me. Here it is. So this is the graph of f of x log base 1/2 applied to x. I have a lot to say about this function like we did with the exponential. It's decreasing on all its domain. It has a vertical asymptote. And its domain is 0 to infinity. Its range is everything. It does not have a y-intercept. It has an x-intercept at 1, 0. It's 1 to 1. It has an inverse function. I would like to write the inverse function. What is the inverse function of this? What type of function will it be? First, exponential. So you have to give me a base and the exponent.
Base 1/2 y is x.
Y equals x would be this line that I reverse the coordinates over. So 1/2 raised to x and log base 1/2 of x are inverse functions.
Oh, okay.
What will be for this one? So this was f of x equals log base 5 of x. I want to also write the inverse function for this function.
5, yeah.
Very good. Very good. So here's a question. If to x, I apply 5 to the x, and then I apply log base 5 of x, how much will I get?
Say it again.
Yes. So I have x. I apply this function to x, and then I apply this function to x. What will be the answer? Exactly, because I'm applying two inverse functions in a sequence. What if I apply this and then this? Same thing, x. Because they cancel their effect on x. Very good. Awesome. I would like you to invent a log with transformation so we can graph it. Okay, I'm going to say negative log, give me a base,
5.
x plus 2, let's say plus 2. I want you to give me the domain. What do I have to write to find the domain? And then we'll talk about transformations on this function.
X plus 2.
Perfect. Which means x greater than negative 2. So the domain is negative 2 to infinity. Perfect. So base function. Which function did we use to create this one?
1, 5.
Very good. First transformation in order of operations on log base 5 of x.
Shift 2 left.
So 2 left, log base 5 of x plus 2. Very good. Transformation 2 on transformation 1 in order of operations.
So reflected on the x-axis.
Reflect with respect to the x-axis. And number 3 is a transformation on number 2. Very good. Good. So let's graph. Oh, I lost 13, 14. Okay. So I need to graph a log function. Okay, I'm thinking. When I graph a log function, I have to identify the base first. If the base is greater than 1, the function starts this way, crossing at 1, 0. If the base is less than 1, then the function starts this way, crossing still at 1, 0. So which one is it? Is it an increasing function crossing at 1, 0 or decreasing function crossing at 1, 0?
Increasing.
Yes, because the base is greater than 1. Okay, so here's my graph for now, log base 5 of x. It has a vertical asymptote at 0.
Right.
Then you said graph this function, shifting it 2 to the left. What do I have to shift first? Yes. So now the vertical asymptote shifts first. This is x equals -2. And then this point, this is my marker, moves 1, 2, right here. So it's the same graph, no change. But this is log base 5 of x plus 2. Then you told me to work on this function and do the transformation of reflecting. So I don't have to do anything other than this. So this is negative log base 5 of x plus 2. And then you said the last thing you need to do is shift the whole thing up 2. Here's my marker, and I go up 2. So here's the new graph. I don't know where it's going to cross. I don't know if it's crossing here or here. I don't really care. I'm only interested in a rough estimate of the graph. If I want to determine the x and y-intercepts, it will be no problem. So this is negative log base 5 of x plus 2 plus 2. This is the final graph. Okay. I know it's a lot in one day, but I don't think it was that hard. Was it hard so far? No. So I will end today. No crossword today. Everyone gets 10 points. I just want to end today by practicing the 4 properties, 3 properties, and the change of base. These 3 properties are specific to log. No other function has these properties. So this is 4.4. Properties of log function. There are 3 properties. Here is one. Log applied to a product. We don't need parentheses. I can write log xy. I don't need log parenthesis x times y. So this is a product. So this is log. They have to be the same base. So if you want to put, for the general case, just put base a. Log base a of x plus log base a of y. Like with the trig identities that we looked at last week, this is a dynamic relationship. I can get from here, here, or I can get from here, here. So if you give me log applied to 5 times 9, I can say it's log applied to 5 plus log applied to 9. If you say log applied to 5 plus log applied to 9, I'll say it's the same with log applied to 4 times 9. So here's an example. Let's say log of 3x. Let's say it's base 10, common log. So this is the same with, what would you say? So this is the product rule. Now what if I say to you, or write log base 3 of 11 plus log base 3 of 3. What will you say? This equals to log base 3 of? Exactly. You have to do the product. Good. So this is one rule. You will never encounter this again. This is it. The log function has this property. Here is a log applied to a ratio. So this is a ratio. What do you think? Just a wild guess. What would the answer be?
Log x minus log y.
That's it. Oh, I didn't mean that. I meant this. Good. Here's an example. Base 10, 7 over 3. What will you say this equals to? It's common log. Common log.
Log 7 minus log 6.
So that's the quotient rule, or the ratio. One more, last one. So this is the power. So the first one was product rule, the second one was quotient or ratio rule, and this is a power. Here, this one. It's a base raised to a power. So here is the answer. This goes in front as a factor, which means multiplied, not added or subtracted. So this is b times log base a of x. So here's a question for you. If I say 3 log of 4, what other way you could rewrite this expression? Log 4 cubed indeed. Very good. So let's look at a few examples. And then word problems. So these are on page 329. We already looked at the change of base formula. Let me write it here one more time. Change of base formula. So if I want log base a of x, and I want to change this into base 10 or base e. Can anyone remind us what was it equal to? It was log of the number over log of the previous base. And what do I have here? If I don't want to use common log, but I want to use natural log. So this is the change of base formula. So please choose first from 1 through 44, in which we are evaluating 7 through 18 first, and then 19 through 44, and then 45 to 54. So we're on page 329, from 7 through 18 first. 14? Very good. So we have log base 3 of 100 minus log base 3 of 18 minus log base 3 of 50. It's a perfect example. I just want to make sure that we understand this so we can condense or simplify this quickly. Okay, let's come back to the properties or the rules. Notice one thing, two things here actually. If this is a product, which means x and y are from the numerator, right? There's no denominator here, right? Both of them are from the numerator. Both logs will have positive in front because x and y come from the top. Now let's look at the next one. See, the denominator is y. Yeah. It comes from the bottom. It will have, when I expand it into simple logs, it will have a minus in front. Anything that comes from the denominator of an expression inside log, and I want to expand it, will end up with a minus in front of it. If you remember that, then it will, if you catch on that, then this will be very easy. So I noticed that this is a minus and this is a minus. So if I want to condense this into log base 3, what will be at the top?
100.
Yes. What will be in the denominator?
18 times 6.
Very good. Because they have a minus in front. If they have minus, they must come from the denominator. So now I will simplify inside the expression, inside the log, by 50. And then I will simplify to n 18, and I have log base 3 of 1 over 9. So now I ask myself, this equals a. And this is equivalent to, I shouldn't write it here, and I'm going to erase it. So log base 3 of 1 over 9 equals a number. How do I convert this into an exponential equation? It's log, so I'm converting it into an exponential. 3, very good. So now I'm asking myself, can I write both with the same base, or can I immediately identify a? Let's say we cannot. So the left-hand side is very simple. There is nothing I can do to it. But now I have to think of how to change 1 over 9, and if possible, with base 3.
3 to negative.
Very good. 3 to negative 2 is 1 over 3 squared, which is 1 over 9. So then I know the answer is negative 2. So then this is the answer, negative 2. See if we need another example from here. From 7 through 18. If not, we are going to expand or condense.
$18.
18, very good. So let's look at 18. Perfect pick. Natural log of e raised to e to 200. Don't get scared. Not at all. Not at all. Okay. Ready? So here's what I see. I see natural log applied to natural log e to a power. So I have to use the power rule. So I have natural log e to a number. Where does this number go?
E to 200 goes in front of it.
Right here. So let's write it. So this whole thing will be squeezed in here as a product. So natural log e to 200 times natural log e. Yes, we applied the power rule.
Right. Yeah.
So always remember, I'm trying to teach you when you are given something, just try to make sense of it. If you're given a function, just look at the pattern. What does the function say? What are you doing with x? The same thing here. Okay, it looks like stratified in there, right? One on top of the other. Not really. So it's natural log outside, it's natural log e, and this is a power. I apply the power rule by bringing it in front of natural log.
Yeah.
Good. So now I'm here. I would like to be able to get rid of this if possible. So I'll take it on the side, and I'll ask myself, okay, wait a minute. I have natural log e equals a number. I don't know what this is, but I know how to change it into an exponential equation. So the base
E.
raised to
A number.
equals e. So, oh, okay. I raise e. Exactly. So then this quantity is 1. So what am I looking at right now?
That's log of E.
Good. Okay. So now I'm saying to myself, okay, this is natural log applied to a power. So this is one of the 3 properties that log has. So what would I do with the power?
200.
Times natural log e. But I just established that natural log e is?
1. So the answer is 200.
So it's 200. So don't get scared. They look bombastic, but they are Not. Okay, we need another, or we can go to expanding and condensing. Are we okay? So please choose from 19 through 44. Now you're going to say, fine, you give us a log of a complicated expression and you want us to change it into simple logs. And then the next step, and the last for today, will be we're going to be given a long chain of logs to condense it into one log of a complicated expression. What's this game all about? We need it for equations. That's why we need to learn this. Okay, can I choose the first one?
Yeah.
Okay, so I'm going to choose 34, which is log of a squared over b to the fourth, the square root of c. How many properties does log have? 3. And they are log applied to a product, log applied to a ratio, and log applied to a power. I always, when I expand, I always have to start with a ratio if there is one. So I'm given this ratio inside log. The quantity from the top will have what log in front? What sign? The two quantities, eventually when I get to them, what sign will they have in front?
Negative.
So tell me how to expand this into simple logs. I have to have log. Do we agree with this step?
Yeah. I mean, it makes it just go ahead and replace it together.
Say it again. You may be right, I just didn't hear.
I was saying, would it make sense to just convert that to C to 1 half?
Yes, and for the power, yes.
Yeah.
I'm just applying the
No, but I
rules.
agree with the step. I'm just saying that.
Right. That would be the next step. So now I'm asking you, are there more ratios in there? In the same step, because you listened to me and you said, okay, I know what this is going to change into. We already, in one step, applied the quotient rule and the product rule. This was the product rule. But since you know that they come from the denominator, you already distributed the negative sign. So we apply the product and the ratio at the same time. Now, what is the last property that I have not applied, but I need to apply? And now, you're right. From the very beginning, there is a power here. Where does the 2 go? There's the power here. And there is a power here. That's it. What is the expanded form, and it's done? 2 log A indeed, minus 4 log B. That's it, and it's done. And no one can do anything else to it. Okay, let me choose one for you to work on. So let's say 36. Log base 5 of the square root of x minus 1 over x plus 1. You have to look carefully at this expression. In this particular case, you cannot start with the quotient rule.
Right.
Which power?
Power rule.
Which property will you start with?
Power rule. Power rule.
Terrible. We have it? Good. So I will write 1/2, yes, in brackets, log base 5 of x minus 1 minus log base 5 of x plus 1, and then I will distribute 1/2. 1/2 log base 5 of x minus 1 minus 1/2 log base 5 of x plus 1. Do not fall into the trap of trying to do anything with log base 5 of x plus 1. There is no rule. No one can simplify log applied to a sum or a difference. We can only simplify log applied to a product, log applied to a ratio, and log applied to a power. Any questions on this?
You would always write it out like that with the 1/2 outside.
Yes. Yes, please. No
Okay.
parentheses.
I just put it in front of each log automatically. Yeah. Well, so I basically skip that step.
Yeah.
Oh, that's fine. You skip this one,
Yeah. I just
and
wrote it.
you wrote this?
Yeah.
Yeah.
That's fine.
Okay.
I'm fine.
Yeah. Because we didn't have anything.
Do we need another expanding, or can we look at condensing, going backwards? Now we're going to be given a lot of logs to condense it into one. Do we need to expand more? Say it again. Condensing. Very good. Okay, let me do the first condensing. Let's say 49 caught my eye. You can choose the next. 4 log x minus 1/3 log x squared plus 1 plus 2 log x minus 1. I'm trying to finish up when you work on the next problem, finish up the other tests. And I know that we all have test anxiety. And I'm in different situations in which I make mistakes. And I say, did I do that? Right? So I know. But somebody wrote pi over 2 divided by 3 equals negative pi over 5. So this is 3 over 1. So pi over 2 times 1 over 3 is pi over 6, not pi over 5. Right? Good. So I'm given this to condense, and at the very end, I have to have log of whatever. 1 in front of it, nothing in front, in other words, 1. And the whole thing in here and no other log, just one log. It's exactly what we did, but in reverse order. So here we started with log of a complicated expression, and we came up with that. And now we are given this, and we want to get to that stage. Okay, so first, I have to get rid of the powers or the quantities in front. So the first is log x to the 4th. Then minus log the cube root of x squared plus 1. And plus log x minus 1 squared. Do we agree with this step? I had to clear the numbers in front of logs. So I took them where they came from. So the 4 in front is coming from x to the 4th. The 1/3 in front is basically the cube root of x squared plus 1. And the 2 in front is x minus 1 squared. Now, my next step is everything that has minus in front will go to the, everything that has plus in front will go to the, no matter what order, because I can rearrange the order. It's a sum of numbers, right? So then I have log x to the 4th x minus 1 squared over the cube root of x squared plus 1. And this is done. I have one log. I have 1 as the coefficient in front of log, and the expression doesn't matter to me. I condensed those bunch of logs into one. Okay, would you like to pick? You can pick whatever you want. If you don't want to pick, I will.
52.
You want to pick 52. Very good. So we have 2 log base 5 of x plus 2 log base 5 of y minus 3 log base 5 of z. Can you just tell me whether you, here's my first question and I'll let you work on this for a minute. Will you distribute 2 or leave the constant outside till and waiting till you're done with the inside and then you'll take care of that?
Leave it as the second.
Right. Exactly. Leave it outside, simplify or condense the inside, and then you apply what you need to apply.
Is that last variable z?
Yes, sorry about that.
I just-
Do we have the answer? Okay. So here is what I would have done. 2 log base 5 of x plus log base 5 of y squared minus log base 5 of z cubed, and then 2 positive positive negative log base 5 of x y squared over z cubed, and then I would have said log base 5 of all this has to get power 2 x squared y to the 4th over z to the 6th. Is this okay?
Yeah.
Yes? Okay, let me choose one.
When you distributed the 2 first, you'd still end up with
Yes,
though,
of
right?
course.
Yeah.
Of course. But I think you would have had an extra step in there. Okay. One more and we'll stop. 53. I think of all chapters, I think you will find this chapter a little bit more exciting and more interesting. I think. I hope. Okay, 53. 1/3 log x plus 2 to the 3rd plus 1/2 bracket log x to the 4th minus log parentheses x squared minus x minus 6 squared, close the bracket. Okay? Ready? Okay? So here's what I would have done. Log 1/3 times 3 is 1. Plus 1/2 can stay. This is minus in front. So I have log x to the 4th over x squared minus x minus 6 squared. Then I have to apply the square root here. So log x plus 2 plus log x squared over x squared minus x minus 6. It's plus, plus, this goes to the top. Log x squared, x plus 2, x minus 3, x plus 2. And this is log x squared over x minus 3. Any questions?